friends, this is Priyanka. Today we are going to solve a problem on crank and connecting rod mechanism. In this video, we are going to learn how to select the direction of angular velocity from the velocity diagram. As well as we are going to calculate the velocity of rubbing at the pin. So first, I will read what is the given problem. The crank and connecting rod of theoretical steam engine are 0.5 meter and 2 meter long respectively. The crank makes 180 rpm in clockwise direction. When it has turned 45 degrees from the inner dead center position, determine velocity of piston, angular velocity of connecting rod, velocity of point E on the connecting rod 1.5 meter from the gudgeon pin, velocities of rubbing at the pins of the crankshaft, crank and crosshead when the diameters of their pins are 50 mm, 60 mm and 30 mm respectively. Position and linear velocity of any point G on the connecting rod which has the least velocity relative to the crankshaft. So this was the given question. Now main important thing is that we have to draw the space diagram with some suitable scale. Now if we observe the dimensions from this crank as well as connecting rod, it is 0.5 meter and 2 meter. That means we can say that 0.5 meter that is equal to 50 centimeter and 2 meter that is equal to 200 centimeter. So I will use here scale 1:1/10. That means for the crank I will use here scale that is 5 centimeter and for connecting rod I will use here scale 20 centimeter. So from the inner dead center the angle is 45 degrees. So if we observe here, we have to first draw the one horizontal line in the form of dash and dot passing through the center O. So this is the center. So here this is the inner dead center and here on the other side there is the outer dead center. So from the inner dead center it is angle is 45 degrees. So at this angle we have to draw here one line that is 5 centimeter. And now here the point B is getting fixed. Now how to draw the connecting rod? So if we observe, we have to take B as a center and in compass we have to take distance 20 centimeter. Now if we select B as a center, then we have to mark an arc on this horizontal line which is passing through this center O. So here is the arc. So this is the point of intersection and this is the end point of connecting rod. So at the end point of connecting rod there is the piston that is getting attached and which is having reciprocating motion along this horizontal line, and this horizontal line is passing through this point O. So in this way we have to show here there is a piston which is having reciprocating motion and this space diagram is getting completed. Now we will move for the velocity diagram. So for that, if we observe from the given data, we have to first calculate the linear velocity. So here rotational speed for this crank BO is given. So how we can define this NBO, that is the rotational speed of B with respect to point O, that is 180 rpm. So from that we can calculate the angular velocity omega BO 2 pi n by 60, that is 2 pi 180 by 60, which is equal to 18.852 radians per second. Now from that, if we observe this OB is 0.5 meter, so linear velocity. So linear velocity, what is the relation? VBO is equal to VB, which is equal to R into omega. So R is this length OB multiplied by omega BO. So omega BO into OB, which is equal to 9.426 meter per second. So now if we observe, we have to select some suitable scale for this velocity and we have to draw the velocity diagram. For velocity diagram we will use here scale 1 meter per second is equal to 2 centimeter. So our velocity is 9.426 meter per second. So what is the scale that we have to take? So 9.426 multiplied by 2 divided by 1. So which is equal to 18.852 centimeter. So this is the scale that we have to take. But what about the direction? So we know that the direction of linear velocity is in the perpendicular direction to the link. So here is the link OB. So we have to take one perpendicular line to this link OB. But we have to rotation. Rotation is the clockwise rotation, that is towards the right hand side. So again, if I draw the perpendicular line with this protractor, because these two edges are perpendicular to each other, so I will align the one edge with this link OB, and with the other edge I will draw here one perpendicular line. So this line will indicate the direction, that is, this is the velocity of B with respect to O, and the direction we have to take, that is in the same direction of this rotation of this crank OB, that is in the clockwise direction, that is towards the right hand side. So I will take here. So this is the direction, that is in the upward side. So now while we are drawing the velocity diagram, here the point O is fixed point. So I will select for the velocity diagram, here is the point O. That is, for velocity diagram I will use the letter with small letter, that is small o. Now I have to draw the velocity vector for this scale 18.852 centimeter, and this is the direction. So first I will take the direction parallel to this VB from space diagram to the velocity diagram. So 18.8, I will take initially 18.8 centimeter. So here is this is the initial point, here is the final point, so final point is point B. So this is the vector OB. So this vector indicates us the velocity of B. So I will say that VB. Then next, now at point B, this connecting rod BP is getting attached. So again we have to draw the velocity. So we know that velocity is in the perpendicular direction to the link of this BP. So I will again draw one perpendicular line to this link BP. So with the help of protractor. So here this is the line, that is the perpendicular line. But currently we don't know where is the direction, that is in the downward direction or the upward direction. So now currently I have to draw one line, but passing through this point B and parallel to this perpendicular line. So I am taking here with the help of roller, this is the line parallel to here, and passing through B, on both sides of B I will draw the line. So in upward direction and in downward direction also. Now again, if we observe at this end of this connecting rod, there is the piston that is getting attached and which is having reciprocating motion along a horizontal line, and this horizontal line is passing through the fixed point O. So how to show this motion in velocity diagram? So whenever there is the reciprocating motion for slider or piston, we have to show as it is, that is in that direction of motion only. So direction of motion is horizontal and it is passing through O. So I have to draw one horizontal line passing through this point O. So again, if I draw here, now currently I don't know in which side that I have to take the horizontal line. So I will take here on both the sides the horizontal line. So I will draw here the motion, that is the horizontal line. So if we observe on the left hand side, there is no any intersection of point, but towards the right hand side there is a point of intersection, and this point of intersection is nothing but the point P. So I will use here the small letter P. So we can say that here the direction of velocity is initial point is B, final point is P. So it is in the downward direction, and it indicates that the velocity of P with respect to B, that is velocity of P with respect to B. So I have to show here also the downward direction. So I will show here, this is the downward direction, and I will say VPB. And here, that is the motion of this piston is from point O, because O is the fixed point, and towards the right hand side. So I will say VP. That is the velocity of this piston. So I have to show if the direction of this velocity of motion is towards the right hand side direction. So in this way, this velocity diagram is getting completed, and from this diagram we have drawn here the velocity, that is VPB, and here I will say VP. So we can also say VPO, but point O is fixed, so only we can say here as a velocity of piston as a VP. Now we will move for the calculation part. So first question is that we have to calculate the velocity of piston. So if we observe the velocity of piston, that is piston is having reciprocating motion and it is indicated by the vector OP in this velocity diagram. So if we measure length for this OP, then it is equal to 16 centimeter. So here is the scale, 1 meter per second is equal to 2 centimeters, but our measurement is 16 centimeters. So here is the question mark. So again we have to take cross multiplication, that is 16 into 1 which is equal to 2 into x, that is x is the unknown term. So we can easily find out this x, that is 16 by 2, that is equal to 8 meter per second. So this is the answer of the first question, that is the velocity of piston. Then we will move for the next, that is the angular velocity of the connecting rod. So here is the connecting rod BP. So first we will calculate the linear velocity. So what is the measurement of this length BP? So if we observe the vector BP, that is equal to 13.5 centimeter. So with this scale, 1 meter per second is equal to 2 centimeter. So for 13.5 centimeter it is 6.75 meter per second. So this is the linear velocity. Now from that we can easily calculate the angular velocity. That is, angular velocity is equal to linear velocity divided by the length in meter. So length of BP in meter, that is 2. So 6.75 divided by 2, which is equal to 3.37 radians per second. Now most important thing is that we have to define its direction. So how to define its direction? Now if we observe here, velocity of P with respect to B, that means B is the center and direction of this velocity is in the downward direction. So with the help of compass, if I take B as a center and if I move the compass in the downward direction. So what is the direction? So if we observe, here is the direction, that is in anti-clockwise direction about center B. So we have to write answer, that is anti-clockwise direction about B. So this center is important, that is when center is B, then it is anti-clockwise direction. And here for omega PB, here is the answer, that is 3.37 radians per second. Now the next question is that we have to find out the velocity of point E on connecting rod. So it's a distance from the gudgeon pin is given, that is 1.5 meter. So we can say that from this point P, here is the gudgeon pin, the distance from this point P to E is 1.5 meter. So now how to find out the velocity of this point E? So for that we have to locate in the velocity diagram the point E. So this point E is on the connecting rod, that is on the link BP. So here is also vector P to B. So here we have to locate the point E. So how to locate? So if we observe the space diagram, we know the distance PE and we also know the distance PB. So it is in proportion, that is space diagram is in proportion or is made with some scale with this space diagram. So we can say that PB by P, suppose we will take the ratio, that is PE divided by PB, we have to take the same ratio here, which is equal to PE divided by PB. Now the exact location of point E is unknown, but we know what is the total length of this PB. So we will put all the known values. So PE 1.5 meter, PB 2 meter, and then what is the in velocity vector PB, that is 13.5. So here it is unit is meter. So this meter is getting cancelled and here unit is millimeter. So when we calculate this unknown term, that is PE, we will get answer in millimeter. So this PE is equal to 10.125 millimeter. So we have to take distance 10.125 millimeter and we have to locate here the point E. Now question is that the velocity of the point E. So this point E is on the connecting rod, but here the point O is fixed and about which the crank is rotated, which is connected to this connecting rod. So we have to join this point O to E and this vector will represent the velocity of this point E. So I will say that this vector VE and the direction is from O towards E. So if we measure this vector OE 17.5 centimeter. So what is our scale? 1 meter per second is equal to 2 centimeters. So with that scale VE, that is the velocity of point E, is equal to 8.75 meter per second. So this is the answer for the third question. Now we will move for the next question, that is the velocity of rubbing. So at different points we have to calculate the velocity of rubbing. So what is the first? That is, we have to calculate the velocity of rubbing at the pin of crankshaft. So pin of crankshaft is at this point O, because we know that the crankshaft is here at the point O, for which this crank is getting connected. So at the pin of crankshaft, that is at point O, diameter is given 50 millimeter. So we have to convert it into meter, that is 0.05 meter. So at the pin of crankshaft, if we observe, only one link is getting attached, that is this crank OB. So we have to take omega OB. So DO by 2, that is this diameter divided by 2 multiplied by omega BO. So when we put the value, then we will get 0.47 meter per second. Now in the same way, again at the pin of crank, we have to find out the velocity of rubbing. So here is the pin of crank at this point B. Now if we observe, at this point B there are two links, that is the link OB and link PB is getting attached. So if we observe, this link OB is moving in the clockwise direction, and this link PB with respect to point B, we know that it is moving in anti-clockwise direction. So both are having opposite direction. So what is the formula? So at this time we have to add the angular velocities at the point B. So what is the diameter at this point B? It is given 60 millimeter, which is equal to 0.06 meter. So at the pin of crank, that means at the point B, how we can calculate velocity of rubbing? That is dB by 2 in the bracket omega BO plus omega PP. So why we are adding? Because omega BO is in clockwise direction and omega PB is in anti-clockwise direction. Suppose they are in the same direction, we have to subtract it. That is the angular velocity, we have to use the subtraction. But when both are in opposite direction, then we have to add the omega. So we know we have already calculated, so we can use that value and we can find out the answer. So 0.6675 meter per second. Then at the pin of crosshead. So at the pin of crosshead, that is here at the point C, here is the crosshead, that is at point C, we have to find out the velocity of rubbing. So DC is given, that is 30 millimeter, 0.03 meter. So at the pin of crosshead, we can say that DC by 2, but at this point C, only one link is attached, that is PB. So this PB, that we have to take omega PB. So omega PB is, we have calculated value earlier, so we have to use that value and we will use here, that is answer is 0.051 meter per second. Now we will move for the next question, that is we have to find out what is the position of the point G on the connecting rod which is having least velocity with respect to crankshaft. So we have to find out such a point that with respect to crankshaft, that is at this point O, there is the crankshaft, there is having least velocity. So what is the rule to find out the least velocity? So we have to refer the velocity diagram. So we will get the point on the crankshaft. So for point on the crankshaft, that is this point O, with respect to this point on the crankshaft, at which point there is the least velocity on this connecting rod. So here is connecting rod BP. So here is the vector BP. So on this vector BP, we have to draw such a line that which is perpendicular to this BP, but it is passing through this point O. So this is important task, and how to draw this perpendicular line. So we have to use the protractor. So for these two edges are perpendicular to each other. So if we observe, if we align one edge with this vector BP, and from the other edge we have to check whether the line is passing through this point O. So I will draw here. So I will align one edge with this vector BP, and from the other edge I have to draw such a line that will passing through this point O. So here in the form of dash I will draw the perpendicular line. So if we observe, this is the line that is passing through point O. Now this line in the form of dash and this is the link BP. Both are perpendicular to each other. So I have to show here the angle that is perpendicular. So this is the point, that is the point G, for which there is the least velocity. So I will locate this. This point is the point G. So how to plot this point G on this connecting rod? So we have to refer this, or we have to take the ratio, because both are in some proportional scale. So here if I take ratio from BP divided by BG, or if I take scale, that is BG divided by BP. So now BG, that is the distance, is known, so we have to measure it. So I will measure it, that is the distance BG, that is 10 centimeters. So I will take here 10 centimeter divided by BP. So we know what is the BP, that is 13.5, which is equal to, now here BG, so point G is unknown, so I will take here as a BG divided by BP. So BP is known, that is 2 meter. So if we calculate this, so now we have to solve this, because here only one unknown term, that is BG. So BG is equal to 10 divided by 13.5 multiplied by 2, that is 1.48. So I will write here BG is equal to 1.48. So if we observe here, this 10 and 13, this is having centimeter, so it is getting cancelled, and 2 is having unit meter, so its value is in meter. So we have to take this distance B to G is from 1.48 meter. So this is the proportional, that is scale is 1:1/10. So I have to take here 14.8 centimeter distance. So I can plot this value here. So point G is here. This is the location of this point G. Now how we can find out the velocity of this point G, that is Vg. So for that we have to measure the vector OG. So what is the length of this vector OG? So it is 15.8. 15.8 centimeter. So our scale is 1 meter per second is equal to 2 centimeter. So for 15.8 centimeter, here is the question mark. So if I select this as an unknown term, so 15.8 divided by 2. So here 15.8 divided by 2, that is 7.9. So I will say that Vg is equal to 7.9 meter per second. So this is the velocity, that is the least velocity for this point G on the connecting rod.